Let's take a look at part 2 of slide 14. I have already written out the reactions, so let's look at each one of them. We have, for the first one, oxygen plus carbon disulfide gives me carbon dioxide plus sulfur dioxide. Where do I start? Well, I can take a look here. My carbon is balanced. I leave the oxygen last because I have this oxygen by itself here, and I can easily balance the oxygen because I can fiddle with this without changing everything else. So leave the oxygen for last. My carbons are balanced. My sulfur isn't. I have 1 here and 2 here. So to balance my sulfur, I can put a 2 in front of that sulfur. Remember, you never mess with the subscripts. You only change the coefficients in front of the molecule. I have balanced my sulfur, but I have the oxygen yet to balance. Let's take a look. I have 2 oxygens here. 2 times 2, remember this is multiplied. 2 times 2, that gives me 4 oxygens, plus this 2, that's 6 altogether. And over here, I only have 2. And now I can balance my oxygens without changing any the carbon or the sulfur. I can make this a 6 by putting a 3 as a coefficient in front of my oxygen. And now I have balanced everything. Let's take a look at the next one. I have barium fluoride plus potassium phosphate gives me barium phosphate plus potassium fluoride. Okay, so where do I start? Well, I can start with barium. I have 3 bariums over here, but only 1 over here. I can put a 3 in front of my barium. That balances my barium. I have, now anytime that you see parentheses here, or where you see a polyatomic ion, the way I do them is kind of ignore what's inside. So instead of counting 2 phosphates and 8 oxygens, I just look at this and I say there's 2 PO4 units, 2 PO4s, and only 1 PO4 over here. That's kind of how I look at it. Now you can do it separately. It just saves a little bit of time to do it this way. So I have 2 PO4s over here, but only 1 PO4 over here. To balance that out, I need 2 on this side. I can't put it over here as a subscript. Never change the subscripts. So I need to put it in front as a coefficient. I have 2 phosphates, 2 phosphates. My phosphates are balanced, so 2 PO4s, 2 PO4s. Let's take a look at my potassium and the fluoride. I have 2 times 3, that makes 6 potassiums, and I have 3 times 2, that makes 6 fluorides. I go over here. I have equal amounts of each. Do not put the 6s down here. That they're not subscripts. It will go in front of the molecule as a coefficient. 6 potassiums, 6 fluorides. 2 times 3 is 6. 3 times 2 is 6. And I have everything balanced for reaction number 2. Now let's look at this example. I have magnesium sulfate plus sodium hydroxide, magnesium hydroxide, sodium sulfate. I have covered in previous lectures how to actually write molecular formulas, but remember, it is very important when you mix ions like these that you keep the charges the same. Magnesium is a 2+ charge, and it still remains a 2+ charge. OH is a -1, therefore I need 2 OHs to balance the charge of the magnesium. That's why it's magnesium MgOH2. For sodium here, sodium has a +1, sulfate has a 2-. This is a +1, this has to be a +1 as well. And to balance the charges, because this is a 2-, this is a +1, I need 2 sodiums. That when we write chemical formulas, we manipulate subscripts. So when we write formulas for one compound, we manipulate subscripts to make the charges on the ions, positive and negative ions, equal 0, the total positive and the total negative charges to balance out. When we balance chemical reactions, we look at the coefficients only. Let's take a look. I have one magnesium. My magnesium is balanced. I have one SO4 unit. This is my sulfate. I have one SO4 unit over here, so my SO4 is also balanced. But what do I have? I have 2 hydroxides, so I look at this whole thing, and I have 2 sodiums. Over here I have 1 sodium and 1 hydroxide, 1 OH. Therefore, I need to balance those, and there's 2 of each on this side and only 1 on this side. Do not put the 2 down here. This is the formula for sodium hydroxide. If I add the 2, then I kind of, when we write those, we write the smallest ratios between the atoms. And therefore, it wouldn't necessarily be wrong in the sense that I'd have a 2 to 2 is also a 1 to 1 ratio, but we use the smallest whole number ratios between the ions. And for sodium hydroxide, it's a 1 to 1 ratio. To balance these out, all I have to do is put the 2 in front of the whole sodium hydroxide, and I have 2 sodiums and 2 hydroxides, 2 hydroxides, 2 sodiums, and I'm balanced. Let's take a look at the last equation. I have iron sulfate, or let's see, iron 4 sulfide, actually, iron 4 sulfide reacting with oxygen, giving me iron 2 oxide plus sulfur dioxide. Okay, let's take a look. I have this oxygen here that is not balanced, or it's an odd number. To make that an even number, I can put a 2 in front of my iron here. Therefore, that will make this oxygen easier to balance. So leave the oxygens for last ones to balance, but do make the oxygens, if you see them, that they're odd numbers, try to make them even. I made this oxygen an even number, but now I changed my irons. I have 4 here and I only have 1 here. Therefore, I can put a 4 in front of my iron here to balance it out. Now, how many sulfurs do I have? 4 times 2, that's 8 sulfurs. I have only 1 here. I can put an 8 in front of this sulfur to balance my sulfurs. Now, how many oxygens do I have? On this side, I have 8 times 2, that's 16. 2 times 3, that's 6. So 6 plus 16 makes 22. I only have 2 on this side. To make 22, I multiply it by 11. And therefore, I now have 22 oxygens. 4 irons, 4 irons. 4 times 2, that's 8 sulfurs, 8 sulfurs. 22 oxygens, 2 times 3 is 6, 8 times 2 is 16, 22 altogether. And now everything is balanced out. Okay, I am going to stop, erase this, and then we will move on to the next kind of questions.